This local Ohio man is doing something that just broke the internet, and honestly, we're here for it. This dumb bozo has been sending himself packages in the mail for over a year, but what is inside might surprise you. A local Chicago resident was packaging and sending his own poop in the mail. Yeah, you read that right. And welcome back to Devlog. In the last part, I did something with my 2D platformer game, and in this part, I wanted to make a dungeon generator for no real reason. There's no game with this one, I just wanted to make one. So, the first thing I had to do when making a dungeon generator was pick the kind of dungeon generator I wanted to work with. My initial options were either to use a noise generator system or to use a chunk generator system. For example of how these work, a noise generator system would maybe make a random assortment of noise. If you don't know what this is, think television static. If you don't know what that is, Google it. And then using these values, overlaying different values and creating a dungeon from this. A chunk generation would be slotting pre-made level assets together in order to make an overall level visual. Can you tell which system I'm using at a glance? This was a tricky situation of deciding which one of these dungeon generator systems I would rather use. I think both of them have their own pros and cons, and they're both pretty interesting to code for. Noise generation would make every single dungeon incredibly unique, while a chunk generation would mean that each dungeon chunk could be more intelligently designed and have more intelligent design behind some of its rooms. For example, I can make rooms that actually look very much like a real dungeon room. Well, in a noise generator, that's a lot harder to do because it's mostly just random noise. Anyway, the system I chose was the chunk generator system, with a twist. You see, I thought chunk generation would maybe make dungeon areas look a bit stale and samey after a while, so what I did is I implemented an overlapping system for the chunk generator system, and this overlapping system can then further complicate dungeons even more. I'll explain how this works right now. The way the overlapping system works is that I place chunks in my dungeon. I then have another chunk placed in an exit tile of this chunk, but this new chunk can overlap the previous chunk. I've been saying chunk a lot, but I haven't explained what a chunk is. A chunk is just a room in the dungeon. One room. So I place one room, I place a room next to it, I place another room next to that, I place another room next to that, and if any of these tiles, individual pieces of these rooms overlap, I will have a logic that tests which of these tiles I should maintain and delete. So, two tiles overlap, which one do we delete? We just delete one of them that's overlapping the other, and then we alter the one that is remaining based on the information of the overlapping tile. Basically, a bunch of rooms get squished together in a system, and that's how I make my dungeons. Let's explain the code. So the first step of this system is to actually place a room down. These are handled physically using a prefab system of rooms. Just a number of rooms that can be placed in one specific dungeon generated. These rooms contain a number of tiles. These are just different surface pieces. That is how the game would detect what tile you're standing on. And then in these tile setups, I can just list if this tile is a wall or a floor. These don't have to have any visual information because they're just dummy items that is going to be read by the generator script. What the script does is it generates one of these rooms at random and then places this dummy room item within the level. Once it has done this, it will then check every single tile and add them to a list of possible tiles. After this, we will just delete this object because it's not actually used in gameplay. The important thing is the list that is generated when these rooms are placed. These are the lists of every single tile this room has. So far we've placed a room, we've generated a list of all the room's tiles, and then we've got rid of the room. What we do is we take this list of tiles and we check them against a vector2 array, which is a list of objects by x and y coordinates. of the pre-existing tiles in this room. This doesn't mean any room tiles are placed yet, it just means we have a logical setup that is keeping track of every tile that should be placed in the room so far. So these are all previously placed tiles. And then all we do is we check if there is a tile existing at position X and Y, these being the tile's coordinates, at that coordinate in our list of tiles. If there isn't, we can just place this tile at that position, meaning that we're just going to add this tile to our vector2 array, keeping track of all of our tiles. This leads me to organically talk about how tiles are organized in our vector2 array. All we do is we generate a list of arrays. It is getting very complicated with all the lists. I promise it makes more sense in the code. I promise, I promise, I promise, I promise. We generate a list of arrays. These are being 100 unit chunks in the game. And then the coordinates of this chunk. So if the coordinate of this chunk is 0, 0, then this list of tiles in this chunk is going to be list of tiles from x0 to x100, y0 to y100, and a square encompassing this area. This vector2 array is going to contain every single tile that needs to be placed within these sets of coordinates. This is very easy and simple. So whenever we need to place a new tile, we will check its coordinates for if there is a list of these tiles. If there is, we then check the position of the vector2 array relative to this tile's position. So if the tile is at position 58 on the x-axis and 2 on the y-axis, we will just fetch the vector2 array that contains the tiles in this coordinate chunk. Then we will find the tile that is in this array at position 58 on the x-axis and 2 on the y-axis, this being the vector2 array listing. If you're having trouble visualizing this because it's very difficult to visualize because it's a bunch of lists, all you need to do is imagine there is a bunch of grids and graph paper, and as the system is keeping track of chunks, it is scribbling in information in one of the grids and saying what the information of that tile is once a tile has been placed in that position. I've talked a lot about tile placements, but I'm going to be honest, making an organized list of every single tile that needs to be generated in the system, and then the information of the tile, and then placing them into organized 100 segmented vector2 array chunks, and then keeping track of how those are organized in world space, was legitimately the hardest part of this entire generation system. Everything else was super easy, but organizing things into lists and lists and within lists was just the worst. And there was a reason I had to do this. First of all, it's organized. Second of all, there's no other reason. Third of all, it makes it a lot easier for when I need to get around to replacing tiles or adding things like destructible terrain, because I can easily fetch a tile from a list, fetch what tile is adjacent to it, and so on and so forth, and I don't have to worry with any physics-based systems. Oh, I love not using physics so much. I can just set in a amount of coordinates and fetch tiles based on those coordinates. Anyway, going logically, once we have placed our first chunk and its tiles into our tile listing, we'll generate another chunk. This is done with exit positions. All I do is, for each of our tiles, I will create some of them that will have a logic for an exit position. This means that this tile can be replaced with a floor tile that will lead into another room. So when generating our tiles and adding them to our vector2 list, I will also check if any of these tiles have an exit position, and I will add these to another list. When it comes around to generating another chunk, I will check this list of exit tiles, and I will generate a new room based on one of these exit tiles at random. The tile I pick will have a predisposition to being near the end of the list of tiles. This is so that newer generated rooms are more likely to have another room attached to them, while the first room generated is less likely to have a tile attached to them. Why have I done this? No real reason, I just thought it would be funnier. After I have this logic for where a new room should be, I will generate another chunk at that position. However, I will alter this chunk's rotation slightly based on the exit's position. So for example, if the exit is to the left of our current room setup, we won't need to generate a room that is facing upwards, we will have to generate a room that is rotated 90 degrees to the left to correspond to the left axis. Same to the right, it would be 90 degrees to the right, and the bottom would be 180 degrees flipped, so each room can just be easily rotated to face whatever direction. This is also very easy because the rooms don't have any visual logic, it's just logic for positioning of tiles, so there's no real issue with tiles being flipped or non-organically not fitting together because these are just information-dud objects. So at this point we now have two rooms, and the possibility that a tile has been placed on top of another tile is now possible. What do we do in this situation? Slugglove, what do we do? I will tell you, small child. Using our handy-dandy list of tiles, all I have to do is check the position of a tile when it is placed into the vector2 array of the tiles of this chunk. If there is a tile at this position, I will check which tile has the higher priority. Each tile itself has a number attached to it, set for priority. And this is used, for example, when placing a large room, I will have to have a path from the entrance to each of the exits to make sure that the dungeon cannot generate an impossible room. And then, for this path, I will just have a very high priority for this path, so it can't be replaced. This means that a dungeon is not going to be generated that will have an impossible layout, and you can't just get to the exits. There will always be a path to the exits because the path has a high priority, and therefore these tiles won't be replaced. I can also, for example, place hazard tiles that could have a high priority, and then if these have a very high priority, they will mean that they can't be replaced by a floor tile, or a wall tile, or something less hazardous. We will check for which of these two tiles has the highest priority. If they have an equal priority, then the original tile will be replaced. And then for whichever tile is remaining, I will take a hidden factor called intensity. This is a thing that is not used in this video, but essentially all it would do is if the game was actually going to be made, which probably isn't, I'm just making this for funny. If it was actually going to be made, it would tick the intensity of this tile. For example, if it was a hazard tile, it may replace a spike tile with a tile that spews fire around it, or a tile that makes things explode around it, or something more hazardous. So it would increase the intensity of whatever this tile is by the amount of times something has tried to replace this tile. Or if the opposite tile has a higher intensity, we're going to increase this tile that is being kept by an even greater amount. So if a tile of intensity 5 was replaced by a tile of intensity 0, the new tile will have a tile intensity of 6. This means that dungeons would be getting very wacky with the tiles they are making. But essentially, since this is all at this current point of vector2s and information classes, swapping out tiles is very easy. I just replace one information with another information. We will then create a border around this dungeon that has been made. This current setup is only going to make it so we have a dungeon with a wall thickness of 1. So, if the player was to break any of these walls, as game intended, they would just be in empty space. There would be no tiles around them, not even floors. So, all I have to do is find the limits of this dungeon. I will find the highest point, the lowest point, the leftist point, and the rightest point. I will draw a square around these points, based on the top left, top right, bottom right. I will extend the square by 10 units in each direction, and I will add an empty wall object in any space in this array of spaces that doesn't already have a tile in it. This means that our dungeon now has a barrier of wall tiles, and also is thick enough that the player won't be able to see that there's nothing beyond the dungeon. All we're doing in this system is we're just filling in empty spaces with wall tiles so the player can't see beyond that. In game space, if we were to add a destructible wall system, for example, all I would have to do to make the space infinite is if the player has exceeded these barriers by any amount, I can just add additional blank walls in the radius around the character. So let's say the player destroyed a radius of 5 tiles, I would extend this 5 tiles by an extra 10 amount, and if there's any null tiles in this radius, I will then make these null tiles equal to new wall tiles, essentially filling out any blank space the player may potentially see. This is all completely hypothetical, and this game doesn't exist, so I don't know why I'm telling you this, but that's my plan for destructible tiles. Finally, we have the actual placement of the tiles and the generation of the tiles visually. All this does is read from our vector array and start placing physical tiles in world space based on this array of tiles. So we read each tile in our vector array in our list of every single chunk that has a tile in it. If the tile is not null, meaning there is a tile that has to be placed in this position, we will place a tile in this position. At the current point, this is very easy. I just have a list of visual information classes. We'll generate a physical tile. We'll attach a script to this tile based on the tile information that the player can read when moving around the game. So this would just be if the tile is a wall or a floor at this current point. And we will then set up the tile's visuals. And this is also kind of complicated. So we place a tile and we then need to check the tile's sprite visual based on if there is collision to any direction around it. The top, bottom, left and right, diagonal top left, diagonal top right, diagonal bottom left, diagonal bottom right. Luckily, checking for this collision is very simple because we just need to check if there is a tile in X position and Y position. So once we have all this, we can derive a visual for the sprite based on whatever the sprite is. If the sprite is a floor tile, I will not have to account for collision even slightly, so who cares? We just generate one of the random floor tiles for a base floor tile in the dungeon. However, if the tile is a wall tile, we'll have to have collision based on the immediacies of other wall tiles. So we check if there is any wall tiles within our collision radius, as in the 8 directions around our tile, and then we fetch a relative wall tile based on these collision amounts. What I did for this, and I just used the tile set from Pokemon Mystery Dungeon because I didn't want to draw anything for this little project. What I did for this is I made a sprite object for each of these tile sets and then had a numerical value assigned to these based on what the collision is. So if the collision has 0 collisions, as in there's nothing surrounding this tile, it will be called tile_0. If it has a collision above it, it will be tile 1, to the left 2, bottom 4, right 3, top left 5, top right 6, bottom left 7, bottom right 8. So, for example, this is very convoluted and you don't need to know this. If the tile sprite that we want to use has collision above and below it, this would be tile_1 4 because it has a collision above and below it. This is important, and there's a reason I'm telling you why I named these systems in such a way. It's because I was too lazy to make information classes for each different tile sprite, so I just made the game make it for me. For each tile like this, I will just feed it into the tile visual generation script as a big list, so list of wall tiles, and then it will create information classes for me based on what these tiles names are. So it will read if a certain string number, for example 1, is within this tile's names, sprite name, and then we'll create an information class saying that this is the sprite for collision above and below us because its file name was 1 4. I know that this probably wasn't the best way to handle visual generations for tiles, but I didn't really feel like making an information class for maybe 40 different tile setups, so the game can just figure it out for me. I don't really care that much. After this, all we have to do is check which of these tile information classes has the same collision that this tile has. So we're feeding a tile that has collision above and below it. We'll search all of our tile information classes for a tile that has collision above and below it. This can be multiple tiles, so if we have different visual setups. In this case, we will just find a random one of these multiple tiles that correspond with this collision information. After we have the sprite visual setup, we can just assign this to our new object that has been generated because they all have a sprite renderer. So we make a tile, we have the information, we find the relative visual that the tile has to have, we place the tile in scene. And that's it for this devlog, aka Slugglove programmed something just for the express purpose of putting it in her portfolio. That's not the actual reason I made this. I really like mystery dungeon games, maybe a bit too much, and I'm always very obsessed and interested in how they get designed, specifically the dungeon generation system. Asterix, This is not how dungeon generator systems in Mystery Dungeon games are programmed or designed, even slightly at all. But this would be if I were to make a Mystery Dungeon game, which I might, eventually. If I were to make a Mystery Dungeon game, this would be my current setup for how I would want my dungeons to be generated. I feel like it gives them a whole lot more variety to movement you can have in these dungeons, while also making there to be some complex designs and every dungeon to be unique. I mean, I only have around 20 different chunks that are generated for this demo, and it's been going on for, oh no, a bit too long, and I really can't see that there's a whole lot of very similar dungeon layouts. Obviously they're just walls and floors, so they're going to look relatively pretty similar, but I feel like with this current setup they at least look pretty unique. The next video is back to the platformer game, so don't worry, I haven't abandoned my lovely pet pal just yet. Maybe in a month or two she'll die. Maybe